Today we're going to look at the proofs that are in our notes. By the end of this chapter, you will be doing these proofs on your own. So jot down your questions so we can answer them all. So we are given some information and we're asked to prove that triangle ABC is congruent to triangle CDA. So we're asked to prove that the two triangles are congruent. Now, given our shortcuts, we don't have to prove that all three sides are congruent and all three angles are congruent. We have our shortcuts such as side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg can get us there much faster. So let's set up our proof statement and reason. I like to give more space for my reasons because that's where most of my words are going to be. The good news here is they gave us so much information. They gave us that segment AB is parallel to segment DC. Whenever you see that two lines are parallel, they're right here, you should be thinking two parallel lines cut by a transversal. So all those angle pairs can be used in your proofs. And we will. We'll use alternate interior angles a lot as congruent angles. We may or may not need this. Let's see what else they give us. They give us that angle B is congruent to angle D, and we'll mark that on our picture. They also tell us that segment AB is congruent to segment DC. Let's find that in our picture. AB is congruent to DC. Okay, so far so good. They've marked a lot of this for us, but really you'll be doing most of the marking. They also tell us that segment BC is congruent to segment AD. And great, so we know that two pairs of sides are congruent and one pair of angles are congruent. The question is, which shortcut gets us to our proof the fastest? Look at your shortcuts and see if we can find which shortcut can prove this. And we see that side, angle, side, our first shortcut is already done. So, let's see, our reason is that it's given information. So we can say, because we have given side, angle, side information, we can jump right to that our triangles are congruent. So I'm just going to copy and paste this congruent statement. Triangle ABC is congruent to triangle CDA, and we can say that. Why can we say that? Because it's one of our shortcuts. So all we need to say is side, angle, side. And we're done. That was nice. So sometimes you'll come across really nice proofs, and sometimes they'll be a little bit longer. We're going to have a nice mix today. All right, so here we are given that X is the midpoint of segment AG and segment NR. Whenever you see a vocabulary word in your given information, you should know the definition. So if you have to look it up because I can guarantee you it will be part of your proof. And we're asked to prove that two triangles are congruent. All right, so let's see, statement. And why can we say that? Here, we're going to put our reasons. All right, so statement one, always going to drop down our given information. X is the midpoint of segment AG and of segment NR. And we can say that. Why can we say that? Because they gave it to us. All right, so all we know that X, where the two angles connect, is the midpoint of AG and NR. but I can't really mark up anything in my picture as far as congruence yet because I need to talk more about what the midpoint is. So the midpoint is in the middle of a segment. So X is in the middle of the yellow line, meaning that, so I can say definition of midpoint. Let's talk about the Y first. So definition of a midpoint. So a midpoint divides or cuts a segment into two equal parts or two equal halves. So knowing the definition of a midpoint, I then can say that AX is congruent to GX and NX is congruent to RX. Because I know what a midpoint means. So what we see in our picture is we've got two pairs of sides that are congruent. There's no way to tell whether our RG is congruent or AN is congruent, but I see the yellow and the green line? I spy something that you're going to use a lot. When you have two lines that intersect, write this as an if-then statement. If two lines intersect, which we have, the yellow and the green line intersect, then opposite angles are congruent. Who remembers what these opposite angles are called? If you said vertical angles, you are correct. So we can say that angle AXN is congruent to angle, I need to find the corresponding angle to A, and that's G. GXR are congruent because of vertical angles. Now there's a lot going on in my picture right now, but I can see I have two pairs of sides that are congruent and their included angle. So this would be side, angle, side. That's what I see in my picture. Let me look at my notes to see if that's a shortcut. And it is. So I can say that triangle, I'm just going to copy and paste this congruent statement. ANX is congruent to triangle GRX. How can I say that? Because of side, angle, side. Okay, so these definitions are so important. Everything that we've learned so far, we are going to use. All right, here's some more proofs. All right, so we are given that angle BAC is congruent to angle DAC. Okay, that's marked on the picture. And they also tell us that AC is perpendicular. That's all they tell us. So we're going to have to make some more connections between perpendicular and right angles. We have a little bit of work to do to prove that the two triangles are congruent. Okay, so let's see. Statement, reason. Start with the given information. Okay, I want to make my first statement to talk about how perpendicular lines make right angles. So that's going to be what I want to talk about. So perpendicular lines form or make right angles. So if I know that, I can say that angle ACB and angle ACD are right angles. And the cool thing up next is I can say now that they're congruent because all right angles are congruent. All right angles are exactly 90 degrees. So I can say angle ACB is congruent to angle ACD. Okay, so what I have then is, right, two angles that are congruent. Angle. So I can find, if I look at my shortcuts, I can find an included side is congruent or a non-included side is congruent. But I see that angle or segment AC is the same thing as segment AC, so they have to be congruent. This is going to be a nice trick, but we need to remember that our reason for that is the reflexive property. Reflexive property. I like to think of a mirror, like AC is looking at itself, so it has to be the same. And now look at what we have, angle, side, angle, and that is a shortcut. So I can say that triangle ABC is congruent to triangle ADC because of the shortcut angle, side, angle, where side is included. Awesome. So remember with proofs, the trick is just to take it slow and remember, like you have a teacher or a little kid just nagging at you, why can you say that? Why can you say that? And you're just proving obvious or true statements. Okay, our last proof. Given that segment PQ is perpendicular to QS and RS is perpendicular to QS, we're going to have to state that angle Q and angle S are right angles and that they are congruent. And we also know that T is the midpoint. Oh, here we have that definition again. We can't say that two sides are congruent until we define midpoint. All right, so prove the two triangles are congruent. Okay, so statement, reason. I might have to write small here. Okay, so copying and pasting the given information. And notice that T is only the midpoint of line PR. Not of both lines, just of one, so we'll have to be careful there. All right, let's see, let's start with our right angles. So we know that parallel lines make right angles. So I can say that angle Q and angle S are right angles. We have to define what type of angle they are first. Then we can say that they are congruent. You could say they are 90 degrees. All right angles are 90 degrees or are congruent. Let's see, let's talk now about our midpoint. So now we know that we have congruent right angles. Our midpoint is the middle of PR. So I know that a midpoint divides the segment into two halves. So PT is congruent to RT because a midpoint. So we can say definition of midpoint. And let's write that out. A midpoint divides a segment into two equal parts. Right. And, ooh, I spy, do you see it? I spy vertical angles. When you have two lines that intersect, their opposite angles are congruent. So, so I can say, I can't say angle T is congruent to angle T because angle T makes four angles. So angle, I can do QTP is congruent to angle STR because of vertical angles. Definition of vertical angles. Actually write it out. If two lines intersect, opposite angles are congruent. And now let's see, we have two pairs of angles that are congruent and a non-included side. So, can we have a shortcut or do we have to keep working? Oh, angle, angle, side. So we can say that the two triangles are congruent by angle, angle, side. Woohoo! So angle PQT, triangle PQT is congruent to triangle RST. Oops, forgot my triangle, that's important. By angle, angle, side. Whew, we did it. We have proven 4 proofs. We've proven that angle, angle, side works, and angle, side, angle. We did side, angle, side twice, and we could have done side, side, side as well, but those are our proofs. Today,